Hi students, in this video we're going to cover slopes of lines. So we're going to discuss parallel, perpendicular lines, and lines that don't have either relationship. We're going to review the slope formula, and let's get started. All right, so if you have a graph given 2 points, the easiest way to get the slope is to do rise over run. I'm going to call that point B. So from left to right, we count rise over run. So to find the slope of line AB, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our rise is equal to 10. So 10 is the rise, and then our run is 1, 2, 3, 4, 5, 6. And so 10 over 6 is equal to rise over run. And the simplified fraction is 5 over 3 is our rise over our run. So that's a quick review of slope if we have a graph. So you find the slope of this line segment EF. Remember, we start at the left point and go to the right point. All right, so you should have gotten, we go down 1, 2, 3, 4. So if we go down, that's going to be a -4. And then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we get -4 divided by 14. That reduces to be -2 divided by 7. That is the slope. So if we have 2 points, A has coordinates x1, y1, and B has coordinates x2, y2, we know the slope is y2 minus y1 over x2 minus x1. So we're going to find the slopes of each of these lines. If you want to, you can pause the video and check your answer against mine. So we're going to use this notation. We're going to have the slope, and then we're going to put the 2 letters of the line beside it. So slope of AB is going to be, let's label our points to get x1, y1, x2, and y2. So we have 3 minus 1 over x2 minus x1. So over -2 minus 9, that is going to be 2 over -11. So when you have one negative value, you can just make the entire fraction negative. So we get -2 over 11. Or you can put the negative in the front, and that's the same as -2 over 11. All three of those are equivalent. So then for 2, we have a line segment that has points x, y. So we still have x1, y1, x2, and y2. So the slope of line xy is going to equal 8 minus 3 over -8 minus -1, and that's going to be 5 over -8 plus 1 is -7. And like I said, you can just put for one negative, you can put it in front of the fraction. We get -5 over 7. The last one is we have the line segment VW. So the slope of VW is equal to, let's label our points, x1, y1, and we have x2, y2. So y2 minus y1 over x2 minus x1 is 10 divided by 2, which reduces to be 5, or simplifies to be 5 over 1. All right, so that's a quick review of the slope formula. So there are 3 relationships that exist between a pair of lines. The 2 lines are parallel, and parallel means that the lines never intersect. The lines could be perpendicular. Perpendicular lines intersect at a right angle. So that means like right here, we can put in that symbol for a right angle. Or the 2 lines are neither perpendicular nor parallel, which means they just intersect. They intersect once, but not at a right angle. So parallel lines have the same slope. If we had a graph of if we had have a graph of the two lines, we can just count the rise over run and reduce the fraction. So like say we pick a point here and this point here. When you have a graph, you should choose points where the line goes through the corner of one of the squares. So if we count our slope, we get 1, 2, 3, 4. 1, 2, 3, 4, 5. So the slope of that line segment of this line is 4/5. And then if we take this point and let's see, we'll take that point because the line goes through the corner of a square, we get another slope of 1, 2, 3, 4. 1, 2, 3, 4, 5. So the slope of the both lines is 4/5. We could get that from the rise over run if we have the graph of the two line segments. For the slope formula, if we substituted in each point for the line into the slope formula, we would get 2 points on the blue line. The blue line is the line AB, and the red line is line CD. So 2 points that are on line AB are 5, 5, 6, and 0, 2. So that means that this point 5, 6 is here. And if we did the slope formula, we would get 4/5. And then for the red line, if we use the points 0, -3, and 5, 1, that point, then we would also get 4/5. So algebraically, we have the same reduced fraction. That's how we know the lines are parallel. The reciprocal of a fraction AB is you flip the fraction over and get BA. The reciprocal of any whole number is 1 divided by that whole number. For instance, if we have 5, its reciprocal is 1/5. If I give you the number -3, its reciprocal is -1/3. The reciprocal of 0 is undefined, and the reciprocal of undefined is 0. It works in both directions. And the reciprocal of 1 is itself, which is also 1. 1 is its own reciprocal. All right. So we covered that because parallel lines have opposite reciprocal slopes. And when we say opposite, we mean opposite sign. So opposite sign. So if you have a graph, you can't say they look like they intersect at a right angle. You have to be able to prove that. So you either have to have a protractor or we can count the slope. So if we count the slope of this line, we have this point and that point. This is the line from the other slide. So we know that slope is up 4 and over 5. So the slope of the red line is +4/5. And then say we choose this point and the point that's on the y-axis. We're going to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So the slope of the blue line is -5/4. So -5/4 and 4/5 are opposite reciprocals. The fraction's flipped over and one fraction is positive and the other fraction is negative. So that's how we know they're opposite reciprocals. If we have the slope formula, we would substitute in the points -4/7 and 0, 2, for instance, and we would have -5/4. And then for line CD, which is the red line still, so CD is the red line, I should have mentioned that, we would have the point 0, -3, and the point 5, 1 again. Or we could have also used -5, -7. It won't matter. The slope of the line would still be 4/5. And again, because these numbers are opposite reciprocals, the lines are perpendicular to each other, which means they intersect at a right angle. So all vertical lines are perpendicular to all horizontal lines. Horizontal lines have a slope of 0. This slope is 0, and the slope of all vertical lines is undefined. So slope is undefined. All right, so you determine if AB is parallel, perpendicular, or neither to line XY. If you want to, you can graph, or you can do the slope formula. So I'm going to do the slope formula. We would have for the slope of AB, so we get slope AB is going to equal 3 minus 1 over -3 minus -6. Let's go back and label our points, x1, y1, x2, and y2. So that's going to give us 2 over -3 plus 6 is 3, so that slope is 2/3. And then the slope of CD is going to equal, we get x1, y1, x2, y2. We would have -1 minus -4 over 3 minus 0, which is going to be 3 over 3, which equals 1. And so 1 and 2/3 are not equal. So we would say line AB is neither, we're going to abbreviate, parallel nor perpendicular to line XY. That's how we would answer this statement. Line AB is neither parallel nor perpendicular to XY. Now, again, if you want to, you can graph. I just like doing the math because, in my opinion, it's quicker. So for the next one, we're doing the same thing. So we're going to have the slope of AB. And again, you can pause if you want to try it yourself. You get the slope of AB is going to be x1, y1, x2, y2, and x1, y1, x2, y2. So when you're using a different line, you can go back and use x1, y1, x2, and y2 over again because they're not on the same line. So we would have 3 minus -2 over 4 minus 2. That's going to be a positive 5 over 2. And then the slope of CD is going to equal 2 minus -3 over, so 2 minus -3 over -3 minus -5. And that's going to give us 5 over +2 again. So the slope of both lines is 5 over 2. So we would say line AB is parallel to line CD. And that's our answer. So the last one for us, like figuring out if the lines are parallel and perpendicular, are we have the points 4, -6, and 4, 3 for line AB. So x2, y2. For line CD, we have x1, y1. We have -1, 1, and x2 is 3, and y2 is 1. So the slope for AB is going to be 3 minus -6 over 4 minus 4, and that's going to be +9 over 0. And +9 over 0 is going to be an undefined line segment. I mean, the slope is going to be undefined. And then we get slope of CD. That's going to equal 1 minus 1 over 3 minus -1. Put that in parentheses. So we get 0 over 4, which equals 0. Remember, undefined and 0 are reciprocals. And if the slope of a line is undefined, that means it's vertical. So that's a vertical line, and this is a horizontal line. So we would say AB is perpendicular to CD. We can just put a line segment. We'll put a line over those things. All right, so the last two things that you might see are, so we have this line AB, and we need to plot a point D to create a line so that the line CD is parallel to AB. So parallel lines, that's going to mean same slope. And so we just want to find the slope of line AB first. So find, I can spell, so find the slope of AB. So when we do that, we're going to get 1, 2, 3, 4, and 1, 2, 3, 4. I went too far, so I'm sorry. 1, 2, 3, 1, 2, 3, 4, 5. Let's take, nope. Let's go back one. I need the eraser. So we'll take those out and go back. So we went up 3 and over 1, 2, 3, 4, 5. So we go up 3 and right 5. So from point C, you can either go up 3 again. So we go up 1, 2, 3 and over. So we go up 1, 2, 3 and over 1, 2, 3, 4, 5. And that's going to give us another line that's parallel to line AB. Now from CD, we also could have done, we can go down 1, 2, 3 and left 1, 2, 3, 4, 5. And that gives us another point, so we can draw a longer line, but that gives us a line that's parallel. And so next is we can, we're doing the same thing, but we want to plot a line that is perpendicular to AB. So we need to find the slope of AB again. That's 1, 2, 3, and 1, 2, 3, 4, 5. So it's still, for AB, that slope is still 3/5. Now the slope, so perpendicular, remember, means opposite reciprocal. So the slope of CD is -5/3 because the reciprocal of 3, the opposite reciprocal of 3/5 is -5/3. So we're going to go down from C, we're going to go down 5. So 1, 2, 3, 4, 5, and to the right 3. So 1, 2, 3. And then we'll draw our line segment from this point, and we would get something like that. So that is how we plot a point that gives us either a parallel or perpendicular line, just given one point in an entire other line. So that's going to conclude our video for slopes of lines. Thanks for watching.